Hi, this is Russ Andersson. SynthEyes 1806 features new algorithms and controls that solve shots faster than ever before, saving you time and making much longer shots now feasible to solve in one piece. These techniques complement existing methods and tutorials for solving shots in pieces and splicing them back together. We're going to be looking at solving a 17,700 frame 360 VR shot. The same techniques are equally applicable to regular shots as well. We're going to go to the features panel for starters, and especially because this is a 360 VR shot, we want to increase the number of trackers per frame. We might do the same thing on a regular shot as well, but maybe not quite as high. With that done, we'll run back and we're just going to start up the auto tracker. And generally, very long shots like this are going to be auto-tracked just because it would take too long to generate a sufficient number of supervised trackers that extend through a long enough portion of the shot. Shot is from a Ricoh Theta S, so it's a HD resolution shot. The HD shot does take less time to track than a 4K shot, for example. But the shot's resolution doesn't affect the solve time at all. And really, we're going to be talking about how to improve the solve time in the rest of the tutorial. Now, we do want to have lots of RAM on our machine. This is a 64 gig iMac Pro. We need that RAM not only for the images themselves, but also for tracking data, and also because the solve itself takes a lot of storage when it's happening. So you'll see that we only get part of the shot into RAM, and right now the auto tracker is working its way through the entire shot. One thing that people frequently get wrong is that the RAM cache is storing decoded images that are ready to be displayed, tracked, whatever. So if you have like a 4 gig movie file, it's not going to fit into RAM just because you have more than 4 gigabytes on the machine. Instead, you got to look at what the total size of the decoded images turns out to be. And that's going to be much, much more. And for handling long, high-resolution shots, these say something in the 32 gigabyte and up range is probably appropriate. One other little piece of philosophy while we wait for this to go. For the solve, the objective is to get a good solution as soon as possible. To do that, we want to get you, the artist, involved as soon as the solver encounters a problem so that you can fix it and then resume the solve rather than having the solver waste hours generating a junk solution where you then still have to do a bunch of fix-up work and then restart from the beginning. So the idea of getting the solver to stop as soon as possible is something that's been worked on in SynthEyes 1806. SynthEyes is an artist-driven tool. We do want to take advantage of you and your skills to be able to do as good of a job as possible. So at this point, we'll just wait for the auto track to complete. So we've come up around 5 minutes, 5.5 minutes in total. This is probably a good time to go and save the file out. Before you do that, though, you want to go to the features panel and hit that clear all blips button because that will greatly reduce the size of the file. Now, after an automatic track, some manual cleanup work is necessary so that you don't have bad trackers in there that can wreck the solve and cause the solve to go awry. Now, one way to find those is the Find Erratic Trackers tool, but for 360 VR, that generally isn't too helpful because the 360 VR cameras typically have rolling shutter in each of the different fields, so the shots aren't really all that super stable to start with. So we're going to just go and work on one spot in this shot that definitely has some issues right at the end of the shot, and you'll see that there's a new right-click menu in the time bar. Unfortunately, it goes off the edge a bit, off the edge of the capture window. So I'm just going to say to set the playback start at the click, and now I am going to zoom to the playback range so that the time bar is now set up to a little playback area that I set here at the end of the shot. Now I'm just going to scrub through it and see what trackers are in there that don't look good. And we'll go to the trackers panel and we'll just turn on tracker deletion mode. The one thing that was lurking around in here, you can see there's a tracker right there on the head. Now I scrub through the latter part, and I'll just scrub through a little bit and take out some trackers. I'm just clicking on them. Basically anything that's on me that could be moving around is going to be a hazard. So I'll just take that out. This is just some typical sort of cleanup work, and there are other problems throughout the shot of the same general kind. These beta cameras have these highlights, and sometimes those can get tracked, and sometimes you can get somebody on a tracker on the camera person. So things like that just, should be taken out if at all possible. The thing is, though, that it's unlikely that you're going to always be able to succeed 100%. So you're going to wind up with problem areas, and that's where we want to get the solver to stop so we can look and see what's going on and fix it. So now let's take a look at the solver and the new features there. And there's now a More button up here that brings up the Advanced Solver Settings window. You see there's really a whole bunch of stuff on it, some of which is primarily technical. Some of the things are more relevant on a larger fraction of the shots. To understand really what these controls are doing, let's just start up the solver and take a look at some of its output to be able to understand what's happening. So you can see it started to work its way through the shot. So I'm going to stop it now. Just hit OK. So we've saved away what that initial solution was for however much it did. Now let's go take a look at what's happening. And if you look through here, there's a repeating pattern where it goes and adds frames, and then it adds trackers. And at any given point in time, the solution consists of a bunch of frames where SynthEyes has an initial reasonable estimate for where the camera was, and it has a bunch of trackers, and it thinks it knows what the trackers were doing. And all the other frames and all the other trackers haven't been solved at all yet. As it works its way through the shot, it keeps on adding more frames, it keeps on adding more trackers. And each time it does that, then it goes and does a bunch of optimization that updates everything that it already knows to account for the new data, the new trackers or the new frames that it added. And each time you go and you add some frames or you add some trackers, you're adding a whole lump of error to the scene because the initial estimates that it gets are not that accurate, whether they're for frames, for trackers. And then it goes and it optimizes the scene to reduce the error. So obviously, it's starting from a much larger error. If that error is too large, the solve can go bad and it gets confused about what's happening and it crashes and burns and gets some nonsensical result. So we want to make sure that that doesn't happen. And a really powerful way to make sure it doesn't is by controlling the number of frames that are added at any given point in time. And you can also limit the number of trackers, of points that are added per frame as well. Usually the number of trackers that are added is limited by the lifetime of the trackers, but you can get a whole lot of frames added at once depending on what the situation is like. And that's the one that's really worth limiting, especially for these 360 VR shots that are kind of dicier and higher error to start with. So what we can do is just drop this number down to 80. So we're going to be bringing in fewer frames, a smaller amount of error at any given pass. Now, as I said, each time it adds some frames or some trackers, it goes and optimizes the solution that it has to reduce the amount of error. And it does that in a whole bunch of different steps. Each step is called an iteration. You can see 12 iterations, 10 iterations, 11 iterations, and so on throughout this listing. Usually that number is fairly small in that 10 or 20 range, but sometimes it can require many more iterations, even though they're not really accomplishing very much useful. And that can happen when there's some marginal trackers, or when things are lining up in a way that's inconvenient. So we can set a limit on the number of iterations before it decides to do something about it, decide how many is reasonable or unreasonable. So the default is 200, and I'll point out that all these things have preferences as well. It used to be at 500, but now we brought it down to 200, and here we can even drop that down lower again to 80. And you have a choice of what happens when it reaches that iteration count. And you have the option, if you want to check that box, of just having SynthEyes stop immediately so you can see what's up. Alternatively, you can just say, that's good enough for now. And it's fairly common that the next stage, as you go and you add more trackers, you add more frames, that's going to resolve the situation that was causing the number of iterations to be too large. So we'll set the limit to 80. We'll say, just keep on going. Usually that's going to work out reasonably well. Now, for the overall solution, we're looking for an error that's quite low. For a regular shot, something under a pixel. For a 360 VR shot like these, typically 2 or 3 pixels. So one of the things that we can keep an eye on is what that error amount is. Now, as I said, when it first adds something, the error is very high. But once it completes a given stage of iterations, that error should be low again. And we can set the limit for where we want to stop. So we can just send that down to 2. If that error starts to creep up above 2, that means that something's gone wrong. There's some tracker that's been added into the set that has some problem on the actor or on a highlight or something. So that's another situation where we want to stop. Similarly, sometimes there can be some numeric issues when things go wrong in the solver due to the data that's coming in. And we have the option to do something about that. And I think generally the best idea here is to stop. If you are trying to set something up for a batch operation where you want everything to happen automatically and see how well it can do as a best attempt, then you can just let it continue. So again, you have control over these different settings. Now this next control, convert to far, is one that used to appear as a checkbox out here on the solver panel, where there was a checkbox, never convert to far. And the issue is, what do you do if you see a tracker like this that's far off in the distance? If it's not exhibiting a whole lot of perspective shift, on a regular shot, you can just say that you want to have it as a far tracker. The never convert to far option is used for marginal object tracking shots. And in an object tracking shot, you can never have a far tracker on an object itself. Now, in really long shots like this, you can have a more complicated situation where a tracker that's initially far away later gets closer because you've walked on up to it in this example. And if you initially say that it's far and then later it's actually close, it's going to be a problem. So when you see something that's far away, you don't know if that's going to happen or not. So you can want to just disable it so that it's not solved anymore. But that can actually cause a problem that this make zero-weighted tracker option is intended to address. And the problem is that if you disable the tracker, it can become a zombie. It can come back to life. And that happens because if you disable it, it's still a regular tracker. And if you stop the tracker, the solver, for something else, you fix some other things, now you start up the solver again, it can see that tracker and bring it back to life. And now, although it caused trouble before, it's still now coming back to life, and it might be nearby, it might be far, it might be some of both of them, and it can wreak havoc again immediately. It's a zombie. You want to kill it. And the way that we can kill it is just by making it a zero-weighted tracker, and that says, we don't want to include it in the solve at all. We'll figure out where it is after the solve is complete, and we can decide what to do about it at that time. So I'll bet you didn't think you were going to be hearing about zombie trackers today, but there you have it, my favorite terminology. So at this point, we're ready to go and resume the solving process again. And we'll just start that up. And it's just going to keep on going here. So we're going to step away while it does that. You'll notice there's a little timer down at the bottom. We're going to jump into hyperdrive here and in a couple other spots in the video in order to move things along quicker. Okay, so the solver has stopped. Let's go and find out what's happened. You see that there's a large update encountered and it stopped. Now listed over here at the end of the solver output window, you can see what the last frames that were added to the solution are right around 10,000 frames. So let's just go and take a look at that. I'm just going to click and set the playback in, set playback start, and again zoom to the playback range. So we'll have SynthEyes just run through there. And a couple other notes to this, that you'll see that the trackers that were just added are the ones that are selected. So that can help us identify where possible problems might be. Now you'll see that the solve at the end there gives you kind of that clump of trackers there. That's where the solve is stopped. Now some of these trackers that are up in the trees are pretty dodgy. So there are a lot of false trackers up there where they aren't real locations of actual points. They're places where branches cross. So those aren't really too super to use, despite the fact that there are many of them. And there are a bunch of trackers over here with some fairly high errors. What we'll probably just do is we can delete some of them that look like they might be an issue. And we can turn on tracker radar. That's one of our ways to find high error points. See, there are a couple of them. And this one up here is definitely a spot where the branches are crossing. Now you have to be a little careful just because some of these errors, get to be large just because the tracker is, or the solve is getting to have a problem right at the end, right before it gets very unhappy. See some of these jumping along and around in the tree branches there. So that's going to be typical for this kind of a source material. Notice that I've got the show 3D points only if visible turned on. If you turn that off, you'll see a whole lot of other things from earlier in the shot, which can get confusing. So we just keep it ratcheted down. So we've deleted a couple of trackers here. We might have gotten the right one, we might not have. Typically it is going to be one or two that are really the problems. So we're at a position where we could just simply restart the solve altogether, or just resume the solve as it is. But instead, the thing that's better to do is to do the unsolved frame script. And what this does is actually tell SynthEyes to forget a bunch of the frames that it's already solved, and also the trackers that have been solved based on those frames as well. So it's actually going to go and unsolve both trackers and frames. And effectively, we're backing up the solve a bit to try to eliminate the effect of any of the bad trackers on the solve. We want to get back to the point that we had, a bit further up in the solve where everything was going along happily, and make sure we can resume from that point. So we'll just take out a bunch of that earlier stuff, and then we're going to do our refine from this point. So now SynthEyes is going to load up that previous solution, and it's going to continue again. You'll see, now it's down around 97, 9800 frames instead of up closer to 10,000. And it's going to resume from that point. And what we're going to be looking for is for the solve to continue past the part where it failed previously, so it can then chunk on through the rest of the solve, or until some other bad thing might occur. So, the more tracker cleanup you can do at the beginning, the better you do there, the fewer times it's going to start. And you're going to have to go and putz around and try and figure out what the problem was, back up the solve a little bit, and then restart. So there's definitely an advantage to getting your cleanup done up front if you can. But, the reality is that in complex long shots, some things are going to slip through. And you're going to need to do this sort of process. So there are actually a whole bunch of different things that you can do that are listed in the section on solving long shots in the manual that you can use to try and help find out what there might be wrong at any given situation. And sometimes I've noticed in spots where the camera might have moved a bit and there's a whole bunch of motion blur or rolling shutter, one of the things to do is simply just reduce even further the number of frames that are being added per pass, and just kind of work your way through that one particular section a little slower. And then once it gets past, you might be able to continue and run that number back up. Here we got it at 80, so we might have just run it down to 20 or 30 or something and tried to go through that section of the shot again. But it looks like we're back off and running now, so we'll just wait and see how it goes from here. Okay, so we've had another stoppage here. Let's just again take a look at what's going on. This time we're running out here around 12,000. So let's go take a look at that. I'm just running through these menu options. Sorry that they don't show up in the capture window here. We definitely got something out there that didn't look too great. Again, let's turn on the radar. sometimes these ones that are way off in the distance can be an issue also. So, you can see that there's some isolated frames where things are an issue, but usually that's not going to be quite the problem. It's the ones that do systematically odd things that are the ones that are going to get you in trouble. This spot looked like there was a frame jumping from one spot to another, but it was actually just two different trackers. So we'll just do the unsolve again and keep on trucking. We'll see how this goes. Okay, we're almost here at the end. Looks like we do have another stop, so let's just see what we've got. We're out at 1750. 17,352. Let's just see what we've got. Oops, that wasn't good. Got those backwards. Just need to get my playback ranges set right. This one here looks like a problem. Definitely has some things going on up in the trees there, those overhead trees. Let's just also drop down the number of frames here a bit, just to make sure. Since definitely the camera starts flying around a bit at the end. And we'll back up a little bit again. see how we do. And so there we have it. It's finally run through and completed the solve. See, the number of frames is down to 0. You know, there are still a variety of trackers that were not solved and that you can go back and take a look at to see whether they can be made to be regular trackers again, or you can just leave them as is, depending on what you need to do. You can turn them back to regular trackers by turning off ZWT on the trackers panel. In general, you're going to want to go and look through the entire length of the shot for bad trackers and the corresponding sections of the path that may be affected by them, just to reduce glitches. I think there's one, out here, and this is why I said initially that you can have trackers go wrong, whether it sends the solver off course or not. You don't know. It depends on how it happens to hit that particular tracker. Here you can see that there's one that's on the camera itself, or the shadow of the camera on the ground. So that was one that the tracker managed to successfully ignore. Some of them might still be there and have created a glitch in the path. You can see the path up there. Certainly you need to set up a coordinate system for the whole thing. So you have a bunch of cleanup work to do. That's typical after you complete a solve, and you can see there are various spots where some of the individual errors are high, but that may, if it's just on a single frame, that doesn't really matter. You're just looking for spots where the overall path may be affected too much. So that cleanup work is the same as with anything else. There's just potentially more of it, and you can use sort by error to go and just hit the down arrow a bit, and you can sort through various trackers and then go and find them and see what you want to do about them. Here's one. You can see that I found that's on the hat there. It's not even maybe the one that I was looking for, but nonetheless, it's a tracker that you want to get rid of if you're looking to clean up the track as much as possible. So we could go and do that, take out some of the trackers that may be causing trouble, and then again just refine the final path after that. So I just want to go back and look at the advanced solver settings window again. Most of the controls here are, even more technical. There's one up at the beginning I'll point out that I skipped over previously, which is decimate frames. You'll notice also there's an unsolved frames button up there that you can use instead of accessing it via the script. But decimate frames, we can actually tell it to solve like only the third frame or every fourth frame or something, and have it work its way through the entire shot that much quicker. And it's like, oh, now he tells me after he's gone through the whole thing. Depending on what you want to do, that can be a good option. It might be that you only really need, depending on what you're doing, a reduced version of what happened if there's not a whole lot of rapid motion in the shot. If it's a camera platform is fairly stable, that might be something that's reasonable to use for stabilization if the platform is reasonably stable to start with. So you can go and solve, use the decimate control to solve just that every third or fourth or whatever frame throughout the shot, and then you can go back, drop that control back down to 1, do refine again, and have it go and pick up all the rest of the frames. That'll, take quite a while to do, but it'll tend to be fairly robust just because it's working from the similar solutions right nearby. I'll point out when you are using that decimate frame setting, you have to think a little about how long your trackers are alive. If a tracker has a life of 18 frames and you have it decimating by 3, that means that it's really only contributing 6 frames worth of data to the solve. If you've got, if you're decimating by an even higher number, you're going to wind up that the trackers aren't really supplying very much information. So you need to make sure that the tracker lifetime is fairly large compared to the decimate frames value. The good thing is that even though a tracker is contributing fewer actual frames due to the decimation, it's still giving you the overall perspective shift. The frames aren't all bunched together at the beginning, they're all the way spread throughout it, every third or fourth frame, whatever. So it's still contributing all the information about the perspective shift over the length of that tracker. So that does tend to make the solve pretty robust. During one of the practice runs for this tutorial, SynthEyes was able to resume solving and run through the entire rest of the shot without stopping. That took about an hour and a half straight to do it. So it is kind of cool to see, and each run is going to be different, and it's going to depend on exactly the details of how all the different processors happen to work together and how, exactly when they hit the different trackers that do have some problematic data. So each run will be different. That's what I've got for this, I think, at this point. I hope you've learned a lot. I hope you're able to take advantage of these controls and solve some crazy long shots. SynthEyes 1806 really does run incredibly much faster. The order of magnitude of the solving process has changed in this version, so you can really do some pretty crazy things, and I'm looking forward to seeing what they are. Thanks a lot for watching.